Okay. All right. Oh, no, it wasn't for us. Okay. All right, so 0. 0 almost looks like it fits into these categories, right? But which one includes 0 over here?
The first.
Top one only, right? Because that's where you have your or equal to. There should never be one where it includes both. You wouldn't see or equal to in both spots because it wouldn't be a function.
Well, that wouldn't work in the middle one, right? Because it has to be greater than 0. And 0 is not greater than 0.
Correct. Correct. So we would do 2 times 0 minus 1. That is going to give us negative 1. So f of 0 equals negative 1. Okay? Leah, which one do I pick for number 3, for f of 5? Middle one. And we choose it instead of the bottom one because we got that or equal to with our 5 here. So we should have 5 plus 1 squared over 3. That's going to be 6 squared over 3. 36 divided by 3 will give us 12. Okay, here. All right. For 7, Joshua, which one am I going to pick there? The third one. And what do I get whenever?
4. Negative 4.
I just get negative 4. There is no x to plug into there. So you don't do anything. But a lot of students get it wrong because they'll say like negative 28. Or they'll try to put the 7 somewhere. Right? They'll try to put it somewhere, but you don't. So it wouldn't matter anything above 7. Or anything above 5, really. F of 10 would be negative 4. F of 1,000 would be negative 4. Anything.
1 million.
F of 1 million would be negative 4. There. Okay? All right. Let's see. Bailey, which one would I pick for F of 1? Top, middle, or bottom? For F of 1, middle. Okay? So we'll have 1 plus 1 squared over 3 is going to give us 2 squared over 3, which will be 4 thirds. And then, Lily, which one would I pick for F of 3? Middle one. So 3 plus 1 squared over 3 gives me 4 squared over 3, 16 thirds. So we'll just leave it like that. Yes. Yes. Yeah. If it ends, you probably won't see any on the test where it's fraction form unless it's multiple choice because usually on Canvas I have you type in fractions. So if it is, I'll give you something easy like a one. You know.
5.3333333.
Right. Yeah, I'm probably not going to give you one like that. It's probably going to be whole numbers mostly on those, but there's a chance for fractions. Because you will not have a calculator on the test. All right. Okay. All right. So. Okay. All right. Everybody quiet. Everybody paying attention because it is very, very, very important that you know the concept of what's happening with piecewise functions here. Some of you, this may be a useless exercise because you already understand it well. But sometimes students really have trouble understanding what's happening when you do a piecewise function. So what you're going to do right now is I want you to take your sticky notes and you need to graph these 3 functions separately. Oh, I think there's always one I need to change. Make that 2x plus 4 right there.
So we do it on the same note?
Separate sticky notes. So you should have, on one graph, you've got the line 2x plus 4. On another one, you've got absolute value of x plus 1, and on the third one, you just got y equals 5. No. So you're right. You are just all of our sticky notes will be used on this one problem, so you shouldn't have any left over after this. I'm gonna graph mine also. Graph the whole graph. Ignore the piecewise function down here at the bottom right now. We are just worried about these three graphs. So you're going to graph these three. As you graph these, check with your neighbor and make sure you're getting the same thing. Oh, Luke, we can want to know something about football.
In the trash can. So is it over up to one?
I'll never run.
So it's up to. Let's go. That's great. We learned it's right number one. I think you were thinking.
Bless you. Thank you. My bad. That one is on me.
I would say
Why didn't you touch me?
Smith would have gotten that.
It was kind of a
I could tell. I walked in and she goes, no cans. I'm like, my bad. She's not always upset. It's probably a game rat. What? No. Why was she like angry though?
I don't know. I think
Having a bad morning?
no. She was okay this morning. It's just the boys are annoying. And then whenever they were all like, Luke, touch me.
Oh.
And she was like, we don't have cans. And then you're like, okay, go touch me.
Absolute value.
And I was like, maybe not. But I was like, probably not worth it. If Smith is not going to be happy.
They never stop talking. And they like spread their hands on each other and like smack each other, hit you in the head with the water.
Sounds about right.
Yeah.
I would probably be doing the same thing.
Okay, everybody look up here to make sure you've got your graphs right. All right. Well, it's freezing on me. I think I clicked on it twice and now it's upset with me. Come on. Why is this not working?
It's okay. Let's see what Lincoln University football has. Probably like a campus. Mason Brooks got one this morning too.
Alright, I don't know why my document camera is not working.
Not the hover cam flex.
It's not working.
The hover cam flex is not.
The hover cam flex is...
It's not approved of today's work. That has football. I would say. Pretty sure it's Derek.
Okay. We're going to try this one more time. I need it to work. Come on. Okay. I don't know why my document camera is not working, so let me graph it up here. Okay, let's make sure your graphs are correct. Y equals 2x plus 4 should look like this. Y-intercept at 4, slope up 2 over 1. Make sure you draw your graph all the way out to the edges of the graph. For me there. So that should be y equals 2x plus 4. Okay. Then your absolute value of x plus 1. The absolute value graph is the V graph like this. It is just being shifted to the left 1 unit. So that will look like this on the right hand side. It's going to have a slope of 1. And it will look like this. Draw it on out to the ends of the graph. And then on the left-hand side, it'll sort of bounce back up whenever it hits that x-axis. It is going to look like this. So if yours does not look like that, maybe yours is a little neater than mine, but make sure it looks like that. Yes, it has to go all the way down to the x-axis. Okay, and then the last one, y equals 5. It's just a horizontal line at 5. That is all it is. So it will look like so. Okay, so, all right, okay, so you're going to get your scissors that you're sharing with your partner. Okay, so whenever all right, everybody quiet, so everybody's paying attention. Whenever we do a piecewise function, it is telling us that we are taking 2x plus 4, and we're only using the piece of that function that's below -2. Then we're going to use x plus 1, and we're only going to use the piece of that function that's in the middle there from -2 to +3. And then it's telling us we're going to take 5, and we're only using the piece that is above 3. So I wish my document camera was working here so you can see for sure what I'm going to do. You need to be thinking a lot like we do with domain. We're thinking like vertical lines to cut this off. So if my document camera was working, I would show you exactly what I'm going to do there. But you're going to go in on that first graph, and you are going to put you a dotted line there at -2. You can actually draw it on there if you would like. You're going to take your graph, and you're going to cut it at -2. It is -2, isn't it? Okay. Yeah, -2. All right, so you are going to cut a vertical line at -2. You're going to cut it. So your graph is now in 2 pieces. Okay? Which piece are we using? We are using that smaller piece, that left-hand side. So we are going to take this other piece. We are not going to use it. We're going to crumble it up and put it on somewhere, not the floor. Or I'll let Miss Brown let Miss Aileen come after you for that. But crumble that up. We're not using it. We're using just the left side. So this part is gone. We're crumbling it up.
Oh.
Yeah. All right. The next piece. We are supposed to use from -2, so I'm going to put myself a dotted line at -2 up to +3. Okay? All right. We are going to cut your graph on those 2 dotted lines. So you're going to have 3 pieces on this graph. One at -2, the other one at +3. And which piece of the graph do you keep this time? That middle part. You're going to take the other pieces, throw it away. So this piece right here is gone. This piece right here is gone. Now, I want you to put your cute little graph stickies together. Like that. Line them up. You can stick them to your paper. Remember, this is -2 right here. This is where they're meeting. Because, right, it was -2 on both of those graphs. So -2 is the same. There they go together. Well, your points may not meet. But on the x-axis, it's meeting at -2. Right. Sometimes your points will actually, like, touch, and sometimes they will not. On this one, they will not. No, it won't make a complete line on this one. Sometimes they will, but it doesn't on this one. All right, so we've got that piece. We got one more piece that we have to use. We're going to, on that last piece, we're going to put us a dotted line at 3. We are going to cut on our dotted line. Okay, which piece are we using this time? That smaller piece, this piece on the right. We take this piece over here, crumble it up, keep these in a neat little pile of crumbled papers that you were going to throw away for me at the end of class. Yeah. Yeah. Or somewhere. Don't use them, but don't throw them in the floor, please. All right, and then you can line all 3 of these cute little graphs up right here. And so I'm going to come around so you can see what they should. You can stick them on your paper wherever you can fit them. I had it fixed. You should have something that looks like this. Something like this. Looking pretty good, I think. I wish my document camera was working right now so I could just draw on here. You can do this on your actual graph. So I'm going to put this all together on this graph up here. I'm going to draw it because my document camera is not working. But you guys have your three little pieces there together. Now, this 2x plus 4 was supposed to be used when x was less than or equal to negative 2. So, for this 2x plus 4 piece, I'm actually using this piece whenever I am between, or when I'm at negative 2 or below. So I'm going to put a closed circle right there on this piece of the graph. Then you should have a V that looks like this. Okay? If we look at the function that we're supposed to be doing for that, we're supposed to use that from negative 2 to 3, but do we include the endpoints? No, we don't include negative 2, we don't include 3. So, on the graph, hold on, we're going to put an open circle on this end for that function and an open circle on this end for that function. And then there at 3, the rest of our graph looks like this. We have greater than or equal to 3 for that last part. We use a closed circle for that. Yes, yeah. If my document camera was working, I would have done that, but I think if I reset, like if I shut down my computer, turn it back on, maybe it'll work again, but that'll mess up my recording and I don't have time to wait for my computer to do that. Okay, so this is exactly what you're doing when you're graphing a piecewise function. But, you know, I mean, these little precious sticky notes, I don't actually know how much they cost. I don't know whenever we ordered them, but I'm sure they're more than my regular sticky notes. And there's a lot of y'all, and I don't have enough to pass these out to you every time you do a piecewise function, right? So we won't actually cut these up, you know, every time, but it's what's happening each time. You're using just that piece of the graph, and then it's all lining up together. So let's graph one without sticky notes this time.
Wait, so we would just graph it like that?
Yeah. All right, we've got negative 2, which is just a horizontal line. And what I'm going to do is I'm going to do just like we were doing with the sticky notes. I'm going to graph the whole thing, and I'm going to erase the pieces that I don't need. So if you don't have something you can erase with, you might not want to draw what I'm doing right away. So I've got negative 2. It's just this horizontal line at negative 2. Right? But I am supposed to only use the piece where x is less than negative 5. So negative 5 is right here. These dotted lines are not part of your graph, but I'm just including them so we can kind of visually see where those cut points of the graph are. I am only supposed to use the part of this graph that is less than negative 5. So I'm going to erase all this over here. And we're going to go ahead and do that. Which one do I need for this part of the graph? Open circle. Correct, because it's a less than here, so we use an open circle. Good. Okay, my next graph is an absolute value. It has been moved to the left 3. So absolute value is that V-shaped graph. We're going to move it to the left 3. So that means where it normally touches at 0, 0, that would be moved to the left 3. And I'm going to draw the whole graph, but we're not going to need the whole graph. Now, where am I supposed to use this piece of the graph? Negative 5 up to 1. So I'm going to put myself another dotted line here at 1. I've already got a line at negative 5. And I'm using the part in between those two dotted lines. So I'm erasing what's over here to the right. I'm also erasing what's over here to the left. So on that line, x equals -5, this left-hand side of that piece, which type of dot should I use, a closed or open? Closed for this side because I have an or equal to, so that tells me a closed circle for that. Then what should I use on the right-hand side? Open circle. So if you have an or equal to, you use the closed circle on that end point. If you have just a less than or greater than, you're going to use an open circle. All right, now this next piece is weird because I'm supposed to do 7, which this is a horizontal line, but where do I use that? Just x equals 1. It's just a dot. So at 1, 7, it's just a dot. It equals, so it's a closed circle. You will not graph them by hand because it will be on Canvas, but yes. So you'll either have a graph and then options for your answer choices, or you'll have answer choices and different graphs for your options. And so then we got 3x minus 3. So that has a y-intercept at -3 and a slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1. So that graph looks like this. And I only use this for x greater than 1. So I need to get rid of this left-hand side of this graph. So that part right there is gone. And should I use an open or a closed circle for this endpoint right here? Open circle because it's just a greater than sign right there. Oh, I think it, yes. Yeah. There we go, that looks better. If you're looking at your domains over here, if you have a greater than sign, or like in this case a less than sign, then you're going to use an open circle for whichever side of the graph you are on there. If it's a or equal to, or like in this case where it's an equal, that's when you use the closed circle. Okay, so whenever you see these, they are going to be multiple choice. So it's really important that you're able to identify what type of graph you'll have in each section, right? So you should be, whenever you'll look at your answer choices, let's say they give you this function and there's 4 different graphs that you have to look through. You should know that you're looking for horizontal line over here on the left, absolute value in the middle, and a slanted line over here on the right. So you should be able to exclude a couple of the answer choices, probably just because like the absolute value is over here on the left. They're not in the correct spot. And then after that, you want to look at maybe the open and closed circles. They may make a difference. Or it might be that like, you know, this doesn't have the right slope or something. You want to check each individual piece after that. Okay, questions? Okay, let's see. Yeah, let's do this one. I'm gonna let you guys try this one. I'm gonna cut the screen off and let you guys try it on your own. it's not like it's not a constant.
So,
But you can think of like square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Or you can just plug in some numbers to see like exact numbers that you will get.
like the second graph,
More or less, yeah. But if you're unsure, you can actually, like, if you're unsure, you can actually plug in a point into that.
You can't square root a negative,
Right, so you won't, but you're only using this for x is less than or equal to 0. So you're only plugging in negative numbers, really. So like if you have, if you plug,
square root of a negative,
right,
which would be impossible.
right,
So
then
it's
double
the
negative
square
will make,
4, negative, so if you plug in negative 4, it'll be positive 4, so
correct.
2 plus 3 is 5, so I mean 4 is on 5.
Yeah, 4 should be on 5. You're exactly right. Uh-huh. You can always just plug in numbers for that. So, like, you should have an idea of what it's going to look like, which might be enough if it's multiple choice. But right here, it's not. It'll be enough different that you can at least tell on the graph. So, like, it's possible that the slope might be the only thing, like the only difference between the two. And that's where you might want to take a point and plug those in. Now, like for these, whenever you have to graph, square root of negative x plus 3. Like if you're thinking about plugging in numbers, first of all, you're only using this for x is less than or equal to 0. So you're only using it for negative numbers. So, like if you plugged in negative 1, you have negative 1, and then square root of plus 3. Right? So that's positive 1, square root of 1 is 1.
Got some on the outside.
Okay. And then, like you try to plug in other numbers, you can try to plug in 2 with square root of 2. You don't know what it is. You try to get 3. 2 no square root. Alright? So, negative 4 plus 3 plus 2 plus 3. That's 5. Exactly. This, like, we don't know any of the other square roots until we get to 9. So, negative 9 plus 3. That gives 3 plus 3 plus 6 there. So that gives you an actual
On the warm up.
Okay. All right, here's what it should look like. Yes. It was open, but then, oh, actually, no, you are right. As it is, it should be open. Usually, you don't have that happen. Usually, if you have like the 2 circles ending up in the same spot, usually one of them is open, one of them is closed, and I was making that assumption. But both of these are open, so you should have an open circle right there.
I have a question.
Yes.
How do we find the line for the square root?
So
I get that you like the y-intercept, but then like, and I knew what the graph was supposed to look like.
Just gotta plug in the numbers.
yeah, so you're just plugging in numbers for that. remember, you'll have this as multiple choice, so you will probably be able to look at the graph and tell, oh, well, that one doesn't even look right anyway. So you should have an idea of what the graph looks like. But if you get two that are really similar, but you can't tell which one is correct, you could just plug in some numbers. So like to get these exact points instead of just having like the general shape, here I knew it was going to be at 0, but or 3, 0, 0, 3, I'm sorry. But if I plug in -1, negative 1, this is 1, square root of 1 is 1, plus 3, so I get 4 for that. Yes. Then we would have like -4 plus 3. I skipped all the way to 4 just because I don't know the square root of 2 or 3 without a calculator, right? So I skipped to 4, I got 5, then I skipped to 9 because I know that square root, and that's how I got those exact points right there.
On the test, are we going to do the exact points?
It's possible that you might have to look at some of the exact points because you might have two answer choices that look very similar, but you can plug in numbers to check. Okay, we have this line right here in the middle, slanted line here, from 0 to 2. And then this is a quadratic. It's been flipped, moved right 2, and up 10. So like that vertex of the quadratic ends up being right here. If I graph the whole thing, it would go back down on this side, but of course we don't need to do that because we're not using that part of the graph. So again, the points for this, if you plug in 3 minus 2 squared is 1, 1 squared, -1 squared, 1 squared is 1, -1 plus 10 is 9. So you could just plug in those points to get those exact points, but we should know the general shape pretty easily without having to do that. A lot of times you'll be able to tell by the general shape of the graph whether or not it's correct, but there might be some where two answer choices are really close, so you might need to plug in some points to see which one is actually correct. Okay, questions? All right, we are not going to do all of these last examples, but I do want to do one because all of this crazy stuff right here is just like crazy stuff math teachers make up for you to exercise your brains, right? Like how to actually apply this in the real world, it doesn't really seem like it matters, right? But there are several things that piecewise functions are used for. And one big one that they are used for is taxes. Okay? Because now this is from 2014, so it's old. I need to update it with more current tax numbers, but the same general thing happens. They'll change these rates over here. They'll change where these brackets are, and their taxes are incredibly complicated. So this is just filing your taxes like very, very simply. Whenever you file taxes, you have the option to file, well, if you are married, you have the option to file single, married. You can file head of household. So if you're married, there's several different options there. Of course, if you're not married, you can't file married to someone you're not married to. You cannot be married to an imaginary person.
You can do head of household without being married.
You can do head of household without being married. It is used very often for couples that are divorced. So, like if you're the one that has the kids,
what if
you would file head of household.
What if they're like with one week with the other 1 week? What would you do then?
I don't know. I think your taxes get more complicated. You're going to need to consult an accountant on that particular.
Wouldn't you just do it and then you just divide it by 2?
It's not exactly the same. Lots of places have income taxes, so I don't know that. In fact, like countries that are kind of more socialist are going to have more taxes,
like Canada?
so less. I think most of them use a graduated income. All right, quiet. So, I'm not saying like full-blown socialist, but more in that direction, where things like universal health care, that's more of a socialist, agenda. So in that direction, the more like social programs you have, the higher your taxes are because they got to pay for it somehow. This operates on graduated income. So if you only make $5,000, then you only have to pay 10% of that. Because the assumption is here, if you only make $5,000, you're going to need most of that money to live off of because you only made $5,000, right? And that is not very much money at all. Now, most of you guys probably fall into that range, that lowest tax bracket, because if you work, some of you may not file taxes because you might not work, but if you work, most of you guys probably work a part-time job that probably doesn't make a ton of money because you don't work a lot of hours, and so you probably fall in that lowest tax bracket range. That may be illegal. Do they take money out of your check?
I mean, it was direct deposits.
Yeah, if you're working like at the rec or they're taking taxes out. Now I'm sure the rec is taking taxes out. I'm sure because that is a government entity and would be But now I mean if some people get paid under the table.
Why do you say that? Why do you? Well, like, if you're just, like, working for your grandpa...
Because you're coming to school right now and you're paying $0 for it and somebody is paying for it. You drove on roads to get here that somebody paid for. So any government programs are paid for with taxes. Your police are paid for with taxes. And those are, like, universal things that all people benefit from. Yeah, so that is why they take your money. Yeah.
But like but isn't it since we're like a city school, we don't get as much taxes or whatever?
It's mostly funded by. We actually probably get a little bit more because people who pay city taxes, that also goes a little bit towards us. But your biggest school funding, the biggest thing that pays for school funding is state money. That we get some federal money depending on stuff, but individual states pay the majority of their education. So education and roads are the two big things that states pay for. Federally, you're paying for military, you're paying for, all kinds of federal programs. There's some federal road money, there's some federal school money, but big thing that state does is roads and schools. It's not dependent upon how much we took in taxes. Like, I have to pay taxes myself. So they pay me money, but then I got to pay taxes also. So, but yeah. Yeah, they are. Yeah, just like any other job. Yeah. No, so quiet. All right, so when you work a job, at most places, they estimate your taxes and pull that money out of every check. So a lot of you that have jobs can attest that you were supposed to make $12 an hour, but when you got your check and you worked 10 hours at $12 an hour, your check was not for $120, right? It was for less than that most of the time. So what they have taken out are your taxes. What they have done is they have estimated how much they think your taxes are going to be, and they're pulling it out of every check. Now, you could file your deductions where they don't take any money out of your check. But at the end of the year, you would have to file your taxes, and you'd have to pay the money all at once. Almost nobody does that because if you got all that money in your account, you feel like you can spend it, and you're probably not saving it back for taxes. So that the money out of your check every time allows you, basically you're like saving back that money to pay your taxes at the end of the year. Now, at the end of the year, you will file your taxes. Now, a lot of you may not have to file taxes because you do not make enough money to file taxes, depending on, and your parents claim you, so you may or may not have to file taxes depending on how much money you make. But if you make above a certain threshold, you are going to have to file your taxes. So when you file those taxes, then what they do is the government knows how much money came out of your check every month or week or however often you're paid and went to them. They've got a running total of in 2022, Mallory Wall paid this much into taxes. Okay? They also know when you file your taxes, you file all the money that you made. They figure your taxes. It might be higher or lower than what you actually paid in. Because what you actually paid in was an estimate, right? They were estimating, especially with part-time work. It might not be correct. That estimate might not be correct because you know how part-time work can vary a lot. Sometimes you might work a lot of hours. Sometimes you might not work many hours at all. So it's a little harder for them to estimate what your taxes are going to be on that. But even as a working adult that I get paid the same amount every month. They know at the beginning of the year how much I'm going to make. It does not vary unless for some reason I take a day off without pay, which I've got enough sick leave that hopefully I'm not going to have to do. So, I know how much I'm going to make. Somehow it's still not right at the end. Seems like their estimates would be better for us. But there's a lot of deductions and things they're not taking into account that we can't really do. So, if you make $45,000 per year, this is how your taxes work. This is just straight taxes. So this would be like if you're self-employed, you do not take money out of your check every month, okay? Just straight taxes. So you would pay, if you make $45,000 per year, okay? And this is just federal taxes. They're also going to do this for state taxes. They're also going to do it for Medicare. There's all kinds of things that come out of your check. It's way more complicated than this one problem, but it gives you an idea of how it works. So, you have $45,000. So, if you can imagine that you have all of your money there at once. You have the $45,000. Okay, do not pack up right now. Listen to this. Okay? The first $9,075, you have to pay 10% of that. So, $9,075, you're going to have to pay 10% of that in taxes. That's going to be $907.50.
That's barely any.
Okay, that's only the first $9,075. Okay, so let's keep a running total here. Let me get my calculator. I have only paid taxes. I made $45,000. I have only paid taxes on that $9,075, right? So, I still got $35,000 I still got to pay taxes on. I haven't paid taxes on that, right? It's like I took that $9,000, so they gave me my first little bit. I only had to pay 10% of it. Imagine them paying you out at the end of the year all at one time.
Why would you subtract the $907.25?
All right, so the next amount of money that I'm going to make right here is going to fall in between $9,075 and $36,900. Okay, so imagine that we took like that first amount of cash, we put it in this first tax bracket bucket. We got a bucket for it. Then we paid him $907.50 out of it. The next money that goes in this bucket, everything from $9,075 to $36,900, it all goes in the second bucket. All right, how much money is that bucket will hold? $36,900 minus the $9,075 that we've already paid. The second bucket holds $27,825. All right. I'll show you here in a second. Okay? That's the amount you owe in taxes. Okay? I've got to pay 15% of this. Okay? So I'd multiply it by 0.15. We'll finish this up at the beginning of class tomorrow.